Hello everyone. Today I am going to discuss about third normal form. Before going to a third normal form, in last class, what is by second normal form, what is by first normal form, or what is by functional dependency. Okay, what is by third normal form? Third normal form input. Third normal form input. The given relation in second normal form. Input is in the form of second normal form. And then output is we can get, that is a third normal form. And what is input? A given relation is in the form of second normal form, whereas in the output is the third normal form. Clear? And what is the actual definition of third normal form? A relation schema. A relation schema R is in 3NF extends to A holds. Extends to A holds. Either X is a super key. Either X is a super key or A should be prime attribute. Prime attribute or key attribute. That is either X is a super key or candidate key or primary key. You need not bother about whatever it may be, that is a key. Either X is a super key or candidate key or primary key, or A should be prime attribute. Is nothing but third normal form. What is the third normal form definition? A relation schema R is in third normal form, extends to A holds. Either X is a key or A should be prime attribute. Key means super key or candidate key or primary key. Okay, what is the main drawback of third normal form? What is the main drawback of third normal form? Transitive dependency. No transitive dependency in third normal form. Whereas in the second normal form, no partial dependency. What is the second normal form definition? A relation schema R is in second normal form for every non-key attribute is fully functionally dependent on primary key. No partial dependency in second normal form. No transitive dependency in third normal form. What is meant by transitive dependency? X tends to Y and Y tends to Z is a transitive property. No transitive dependency or no transitive property in third normal form. Okay. That's why removing, that is the X tends to Y and then Y tends to Z. That is the definition, third normal form definition. Observe here, the given relation, the table is a student relation. Table name is a student. Student having student ID, course and then fee. The possible combination of functional dependency, SID tends to course fee, SID tends to course comma fee, SID tends to course, SID tends to fee, SID course tends to fee, SID comma fee tends to course, course tends to fee. These are all possible combinations of functional dependencies. Observe here, first one we find that is a keys or candidate key or super key or primary key. That is a what is the candidate keys? SID closer. What is the SID closer? SID course and then fee. You can get the original relation. What is the relation? R. R is the SID comma course comma fee. This is the relation. Okay, observe here SID tends to course comma fee. What is the SID? Student ID 101, 102, 103, 104, 105, 106, 107, 108. Okay, there is no duplication. That's why student ID is the uniquely identified within the entity set. That's why SID is a, that is a key, candidate key or key. That is a SID, student ID. Student ID. And then combination of what is a SID tends to course comma fee. SID tends to course comma fee is a, that is a uniquely identified within the entity set. That is a course and fees depend on SID. SID tends to course. Observe here, SID tends to course. 101 Java, okay, 102 C, 103 C++, 104 Python, 105 Java, 106 Python, 107 Java, 108 C++. That is a functional dependency is satisfied. First one is the functional dependency satisfied. That is a course and fee is depend on SID. Course is depend on SID. And then SID fee, student ID fee. Why? Because student ID is the uniquely identified within the entity set. That's why the functional dependency is satisfied. SID course tends to fee, satisfied. SID fee tends to course. Functional dependency is satisfied. Observe here course and then fee. What is a course and then fee? That is observe here Java 20,000 and then Java 20,000. And what is the here left hand side? That is based on the property, functional dependency property. What is the property here? T1 of x equal to T2 of x, then T2 of y equal to, T1 of y equal to T2 of y. The condition is satisfied. Observe here first one Java, and what is the right hand side? 20,000, 20,000. That is the functional dependency is satisfied. Whereas in the C++ 15,000 and then C++ 15,000, left hand side are equal and then right hand side also equal. Why? Because property T1 of x equal to T2 of x and then T1 of y equal to T2 of y. T1 and T2 are the tuples, x and y are the attributes. That's why here, observe here, these are all functional dependencies satisfied. But what is the third normal form? Third normal form says that a relation schema R is in third normal form, extends to A holds, and what is the either X is a key or A should be prime attribute. According to our definition, and what is the here SID tends to course, course tends to fee. SID tends to course, course tends to fee is a transitive dependency. What is a transitive dependency? Based on that X tends to Y, Y tends to Z. That's why is not in the third normal form. It is not. The given relation, the given student relation is not in third normal form. That's why we can decompose into two smaller relations. What are the two smaller relations? That is the relation R1, that is the table 1, relation R2. It can decompose into two smaller relations. Why? Because normalization. Normalization is a process of decomposition into smaller relation. Clear? That is the R1 relation. What is the R1 relation? Here, SID. That is the first column SID. Second column course. That is one relation. Second relation course fee. Course and then fee. That is the second relation. It can decompose into two tables. Clear? And what is the first one? 101. 101. Java. 102 C. 103 C++. 104 Python. 104 Python. 105 Java. 106 Python. 107 Java. 108 C++. That is one relation. The given relation R1 is in, is it 3NF? After decomposition, the given relation is the third normal form. Why? Because there is no transitive dependency. And whereas in the second relation R2, course and fee. What is the course? First one is a Java. That is a 20,000. Next is C, 10,000. And then C++, 15,000. Last one Python. Python, that is a 25,000. Python, that is a 2,500. Okay, right? Observe here the given relation R1 and R2. R1 is in third normal form, R2 also third normal form. Before decomposition, the given relation is not in third normal form. After decomposition, the given relation R1 and R2, 3NF. Why? Because there is no transitive property. That is the third normal form. Okay, what is my third normal form? A relation schema R is in third normal form, extends to A holds, either X is a super key or A should be prime attribute. Observe here for each and every functional dependency, that is a SID and then course. SID, course and fee. What is SID is a key, but whereas in the right hand side, may or may not be. That is why the third normal form is satisfied. SID tends to course, SI tends to fee. Observe here SI tends to course and then course tends to fee is a transitive dependency. That's why is not in third normal form. We can decompose into smaller relations. There are two smaller relations R1 and R2. After decomposition, R1 R2 are the third normal form. Right, observe the one more example. GATE 2004, the relation schema student performance. The name, course number, roll number, grade has the following functional dependencies. These are all functional dependencies. That is the first one, name comma course tends to grade, roll number comma course number tends to grade, name tends to roll number tends to name. The highest normal form of this relation schema is And what is the here? I mean functional dependency name comma course. First identify the candidate keys. That is the candidate keys. Identify the keys. What is the name comma course closer? Name comma course closer. That is equal to reflexive property name and then course. Name the course derived grade. Derived grade. And then next one name derived, that is a roll number. Roll number. We can get the original relation. What is the relation here? That is a name, course number, roll number, grade. That's why name comma course number is a candidate keys. Whereas in the observe the second functional dependency roll number comma course. Roll number comma course closer. That is equal to roll number comma course. Roll number course derived what? Grade. Grade. And then what is the next one? Name tends to roll number tends to name. Roll number tends to name. That's why you can get the original relation. What is the original relation? Name, course number, roll number, grade is there. Roll number, course, grade, name. That's why there is a roll number, course also a candidate keys. And what about third one? Name tends to roll number. Roll number tends to name is not transitive dependency. What is by transitive dependency? X tends to Y and Y tends to Z is a transitive property. Is a transitive property. Observe here, and what is the case here? Prime attributes or key attributes. Prime attributes. Prime attributes are roll number, comma, course, comma, roll number, comma, course, comma, grade, roll number, course. What is that? Name, course, roll number, course. Name, that is the name. These are all prime attributes. According to our definition, what is the first one? Name, comma, course number is a key. Why? Because observe here, what is the prime attribute? Roll number, comma, course. That's why according to our definition, what is according to definition? A relation schema R is in the third normal form extends to A holds either X is a super key or primary key or candidate key, and A is the prime attribute. What is the prime attribute or key attribute? According to our definition, name comma course number is a key. Candidate key. Name comma course number is a candidate key. That's why 3NF is satisfied. Second one, roll number comma course number. Why? Because roll number and then course number also, that is a candidate key. And whereas the name tends to roll number. What is the name tends to roll number? Name is a prime attribute. Left hand side. That's why 3NF satisfied. Roll number tends to name. Roll number is a prime attribute. That's why the given relation R is in the third normal form. The correct option is the B, 3NF. What is the observe the question? The relation schema student performance name comma course number comma roll number comma grade has the following functional dependency. What is that first one? You find that is the keys, candidate keys. What is the, how can you find the candidate keys? By using closer. What is the closer here? That is the name, name comma course closer. We can get the name, course, grade, roll number. We can get the original relation. That's why name comma course number is a candidate keys. And then roll number comma course. Second case, roll number comma course closer. What is the roll number course? Derives what? Grade and then name. That's why that is the second, roll number comma course also a candidate keys. And whereas in the name closer, we cannot get the relation, original relation. Observe here, name closer. Name closer. What is that? First name and then followed by roll number. Followed by roll number. We cannot get the original relation. That's why the name is not a candidate key. Roll number is not a candidate key, but prime attribute. That's why according to our definition, either X is a super key or A should be prime attribute. That's why the given relation R is in the third normal form. Okay, right? That is the what is in by third normal form? A relation schema R is in the third normal form. That is extends to A holds either X is a key or A should be key attribute. Okay, that is the 3NF. Okay, before going to the 3NF, what is in by functional dependency? What is in by first normal form? What is in by second normal form? What is in by third normal form? First normal form is the that is it should be states that simple or individual or atomic value. There is no repeating groups or there is no multi-valued attributes. That is the first normal form. Whereas in the second normal form states that a relation schema R is in the second normal form for every non-key attribute is fully functionally dependent on primary key. There is no partial dependency. Okay, that is the second normal form. Whereas the third normal form is nothing but a relation schema R is in the third normal form extends to A holds either X is a super key or A should be prime attribute or key attribute. Okay, is nothing but that is a third normal form. Okay, that is observe the simple example, that is a student relation that is not in the third normal form. That's why we can decompose into R1 and R2. After decomposition, R1 is a 3NF, R2 is also a 3NF. Why? Because there is no transitive dependency after decomposition. Before decomposition, that is the combinations of all combinations of that is a functional dependency. Observe here, SID tends to course and then course tends to phi is a transitive dependency. What is that property? This property is the X tends to Y and Y tends to Z is a transitive dependency, but no transitive dependency in third normal form. Clear? That's why the given relation is not in third normal form. Why? It is a transitive dependency. That's why we can decompose into two smaller relation. What is the first relation? SID course. That is there is no redundancy. 101 Java, 102 C, 103 C++, 104 Python, 105 Java, 106 Python, 107 Java, 108 C++. Whereas that is a course and phi Java and then C, Python and then 2000, 10,000, 15,000, 2500. After decomposition, the given relation are in the third normal form. Okay, in next class, and what is meant by biscored normal form, BCNF. Okay, what is meant by BCNF? What are the property of BCNF? What is the difference between 3NF and BCNF? That we will see in the next class. Thank you.